Hello, everyone, and welcome to Codurance Meetups. My name is Javier Chacana, and I'll be your host today for our talk presented by Lau Llobet, craftsman at Codurance. Lau will be giving us his talk, Code and Diamonds, a journey through code quality value. A quick reminder that this session will be recorded, and you can find this and all of our previous sessions in our YouTube channel, which I'll be posting later during the talk. You can take a look there and remember that Codurance was born from the community and believes in giving back to the community. So if you feel like you may want to share with us or you may want to share with the community, feel free to reach us and we can organize it for you. Without further ado, I'll leave you with Lau. The stage is yours.
Thank you, Javier. Thank you, very kind. Great. So, hi everyone. I am Lau. I will be presenting this talk called Code and Diamonds. It's a tricky title, like it's not a common title. I hope that the talk will be interesting enough for you. And the background of it will be how we go through the code quality and how we can evaluate that. How can we value this from the business side, right? So I will present myself as a software craft person in Codurance, although Javier has already said that. And I'm being not redundant. I'm saying it because taking part in the Codurance Academy, I received a subject which was the seed of all this talk, right? Through my years of consulting, I've been using this content and extending this content and applying this content in many different scenarios. And I'm so grateful I came across this concept called cohesion, right? See, this concept called cohesion. And that is what it all will be about, this talk, right? About what is cohesion and why a business would value it, having a cohesion inside their code, inside their assets, right? And I will explain very quickly what I'm going to show during the presentation. First, we will start with a definition of cohesion, like talking about how we're going to name things, like what is the meaning of cohesion. And I won't be showing the definition and moving on, but I will keep on returning to this definition, right? And this definition won't be like a pre-made one. We will make it custom, and we will make it by merging two definitions that already exist, right? So after having this merge of definitions and stating each part of it, like what are changes, what are modules, and what is software design, then we will show the code. We will go through an example. And I've put this icon here because this part will be quite techy. I will be showing some code, some bugs, some changes, and so. But the rest of the talk will be business oriented, right? So we will put inside of the video when we hang it on the YouTube the exact minute where the business talk starts, and from there on I won't be talking about code. I won't be talking technically, but only from a business and product point of view. How can we take this concept we already defined and how can we value it and cherish it in our companies. And finally, there is no sense of explaining things or speaking concepts aloud if there is no opinion on your side. If you end this talk in a state of indifference or without feeling like you have nothing to say, I would consider that it would be in vain. So please be active during the whole talk, thinking of possible questions, possible insights you find to share at the end, right? That would be great, and your opinion really matters. And let's go ahead. Let's go with the definition. I've put a diamond here. It's all about cohesion and diamonds. But for the moment, I will take all the diamond things away from the talk and focus on, a strict definition on what experts say it's cohesion, right? And what can we learn from that definition? So not only knowing it by heart, but actually being able to reason with it, right? So the first definition of cohesion is from Kent Beck. It's a very mathematical definition. It basically says that an element is cohesive if when we apply a change to a submodule of that element, we don't have to change any other of the submodules of that element. Right, this is a bit tricky to get. I will try to explain it in a plain way. Let's say we have this shelf here where I store my notebooks and I have all the information stored in there. And one day it arrives a change, right? It arrives a notification in a form of a letter saying that there has been an error in my bank account and I'm not having the exact amount I was expecting to have. So immediately I would go to the shelf, I will take my accounting notebooks and update whatever needs to be updated. And if that library, if the design of the library is good enough, it's cohesive enough, I will only take notebooks from a specific shelf of that library, and I won't need to go and edit and to change anything on another shelf, which I have the tracking of my sports, like my personal achievements on lifting weights, and my calendar on which days I go to the gym, and the subscription details I have with that specific gym. That belongs to another part of the library. And this letter, this change in the system only affects a little box here in the whole modular structure, right? So yeah, that's a pretty technical definition. And let's go for the other. It comes from Sandro Mancuso, and he basically states very interestingly that cohesion is a cornerstone of software design. It's the cornerstone, right? When we talk about cohesion, we can talk in that technical way I just said, but at the very end, the implications, the one you can easily verbalize to your teammates, to your colleagues, and to other people in the company, is that the code is very well designed, or the code is not very well designed. It's an actionable word. It's a definition that anyone can understand. So that technical and almost mathematical definition has his, normal life definition. That is, cohesive is a good design. When you talk about a good design code, a good design class, or whatever, you're saying that it is cohesive, right? So if we merge both definitions, because each one of them is a whole world, so let's try to make them collide and to take out of something of there that is new from merging them. We will say that we cannot talk about good design till the code base receives a stress, receives a change, right? There are many, many tons of lines of code that are in production that haven't been touched for years, right? They haven't received any kind of change. They do work, they make their job, they are there, they are necessary, and they are valuable. But because no one needs to change them, there is no much sense on analyzing whether they are well designed or not. There's no point in saying this class is well designed or not if we don't have to change it, right? So we start talking about good design when changes are arriving to us, right? So if the impact of one of these change gets confined inside a sub-element of the code base in a specific region of the code, and doesn't mean to rip all the code base apart to add this change, then we can start talking about good design. And same for the opposite thing. Like if we have to start like rearranging the whole library, rearranging the whole setup for a small change that arrived today, then we would be able to say something, to conclude something on that code base, right? So here we have talked about change, and change can be many different things, right? The most intuitive thing we can think of is like adding features, right? We add features to the code, or bug fixing, we fix a bug. But there's also performance optimizations. That is actually a change on the code base. We can see in some commits, right? If we use commits. And but there's subtle changes that are not necessary features, bug fix or refactors. Let's say like a legal audit, right? There it arrives, the GDPR law, and suddenly all the code has to be changed, right? So if the code base is well designed enough, we will only have to make change in a letter service, which design the letters, in the front end where there's the copies for every page in the system. So depending on the change, different areas of the code will be affected, right? There's also another kind of change we can think of is that, they can be anything. It's very difficult to predict the changes, right? And we have found in clients that there's a company merge, right? Our client is getting merged with another company, and we have to move all the code from one repository to another in GitHub. And that is actually a change, and that actually affects lines of code. And so if we talk about a code design, let's say the language syntax of Go, or the language framework and tools of Go, we can say it's very good for optimizing performance change, for reducing costs of the system. But maybe we can talk about its design in terms of what happens when a Go code base has to be changed from one GitHub account to another. And we can say it is cohesive for one type of change, and it's not cohesive for another type of change, right? So we cannot talk about well-designed software if we don't say to which change this design is ready for, right? We have talked about sub-elements, right? What is these areas of the code base that get affected? And they can range from a class or a library to a microservice or a whole monolith. Even companies can be considered as sub-modules, right? Third-party companies like a Stripe integration or an Auth0 integration. That is a whole element that can be or cannot be cohesive, right? Even we can go also in a micro level. right? Lines of code can be cohesive as well or not. And I think that's a very powerful definition when you can apply it to a line of code or to a whole monolith. And a great thing of this definition is that, well, just a second here. We have called it sub-elements because that was Ken Beck word he used. But I prefer to call it modules, right? Because modules are easy to think that can be replaced, that can be, contain a module inside a module. So I tend to use the module word, right? And I will use the module words from now on. So I was saying, like, one of the powerful things of this definition is that it doesn't really say to which scale you can apply it, right? You can use it for a line of code or for a whole code base. And that makes that word, that phrase of the poet that says, you are not a drop in the ocean, you are an entire ocean in a drop, to come true for code, right? A single line of code can tell you a lot about a whole services setup, a whole microservices setup, right? Because any concern you can have about design, about cohesion, can be applied from macro scale to micro scale, right? It doesn't matter at which scale you apply. I'll put an example here. At some companies, there's an interview where they ask the candidate to actually solve, like an ATM machine, a bank account problem with 2 or 3 classes, right? With 2 or 3 functions, or, with very small elements. And from that small setup, conversations can be raised about, event sourcing, state and mutability, single responsibility, solid principles. You can have any design decision that applies at a smaller scale. It's probable that it can be applied to bigger systems. We have a small example here. It's a piece of code similar to one of our clients. And what we do have here is the validation of we are allowing a user to post on an endpoint, right? And we want to validate that it is a whitelisted user before allowing him to, or her to post the information, right? So this is in Clojure, but here this single line, this little drop of line of code, we basically are taking the whitelisted user list from configuration, and we're seeing if it's contained, if the user that has requested it is contained in that list, right? So this small line of code can grow a lot, right? It can grow like this request can be encrypted. So we would break this apart and have a module for that. We would say a decrypting module for that. We can say that the configuration is no longer static and needs a database. And actually, we need user management for that database. We need to create, observe, and create, update, and delete the users in that database. These 2 lines here can grow even to a whole company size, right? There's Auth0, which is actually doing what this line is doing, right? And things we can say about this line, like, for example, can we separate these 2 lines in a safe manner, right? Can we optimize and decrypt first the user and then look at the list and see if it's there? And we can use many decrypting algorithms for that. And this contains function, how expensive it is, like how many users does it have? Is it n of 1 or n of O? So we can even think like what would happen if we had different whitelisted user lists depending on the encrypted algorithm we're using for the authentication token where we take the user from. So from this small line of code, it can really grow to a huge size, and that is discussing about cohesion of this line can be useful to picture the team structure of Auth0, right? For example, it can help to figure out what are the implications of this design. Great. So let's go for an example, because this definition is a bit abstract. We've gone through a very high level and very theoretical definition. So we will see an example now. It solves a problem, right? This problem is a very common problem among programmers, that is counting how many times a day you have to program. Even we have meetings, right? We do have meetings during the day. So we've built a small program that basically takes all the meetings, and for each meeting we pass the next meeting, and inside that method we subtract the time of the current meeting with the next meeting, right? And after that there's someone iterating all these meetings and adding up the available time till next meeting, right? So here is basically what we have said. We have a meeting class, and we're calculating the time till next meeting. And there is a corner case, right? Before the daily, we don't want to add any programming time, because we will be setting up things for the day, right? So if the next meeting is not a stand-up, we can compute the time normally. Otherwise, we take a default value that is 0 for the meeting's available time, right? And we have another design, right? I'm not going to consider here which is best or worst, depending on code smells or so. We're going to see how these two designs react to a specific change, right? And well, let's take a look at the second design. It's basically the same, but here, this 0 that is used to be put in here, it's made explicit in this calculation that when it's not in a stand-up, when it is in a stand-up, we don't count the time. So let's stress these designs, right? Let's put a change on it, and let's see what can we say about it, right? We will be able to say something after applying a change, right? So the change will be that we are adding an extra slot at the end of the day with the average time we spend programming, because we don't have an end of the day meeting, so we cannot subtract 2 meetings, and we basically are assuming this value for every day, right? So what about this solution, right? There's a programmer coming in the team, maybe it's his first day, maybe he's a programmer that for a long time doesn't see this code base and actually comes up with this solution, right? And this is actually setting a default value for this specific kind of meeting. But it presents some problems, right? with one of the solutions, what can happen is that this value gets overwritten, right? And while in the other solution, it doesn't, right? What could happen here is that if the user was not relying on this variable here in this private variable, if all the logic on calculating time would be contained in a single function, right, like in here, and the class would be stateless, this problem would not occur, right? So if we removed this attribute here, we would have a better design for this kind of specific change, right? And we can see here that we can get to our cohesion definition we have seen. We have a module, which is the class, and a submodule, right? And we have introduced a change to it, but this change has also been done at other parts of the code, right? So it's this design is more difficult to track, is more difficult to reason about, right? Than a code that has all the changes all together, right? If we didn't have this private attribute, and the programmer that added this second corner case would see in this function, they would basically add a third option here in the function, and the code will be free of bugs, right? So this design I would say that this design is better for this kind of changes, right? But can we say that this is a bad design always? I wouldn't say so, right? If we had to do some specific logic for counting the available time till next meeting for the end of the day, let's say that on Mondays and Fridays, this 1.25 gets changed for a 25, or a special algorithm is created. Maybe it would be a good design decision to build a class with logic inside and with their own attributes and so. So again, it will depend a lot on which would be the changes that will come in the future, right? If there would be like 4 or 5 or 6 corner cases like these ones, like this 1.25 and that 0, I would say that the design would need another kind of setup, right? If the meetings shall calculate also the resting times, like you take a short break of 10 minutes every hour or so, maybe it makes sense to have different logic for the last meeting of the day time, available time, right? So that's the example. Bear in mind this diagram here, like keeping the changes inside the modules, because that is the definition we have been talking about. And now let's go business, right? Let's say, okay, this is a very elegant, or this is a very interesting concept. This is something it's nice to think of when we're talking about code, but what is the real impact on the business? Which metrics can go better? Are we going to deliver faster? Are we going to have more happy people in the team? What's the value on doing this kind of reasoning, on caring about the design, right? So first of all, I would say like cohesive code is like diamonds, right? It's accurate, it's precise, it's frictionless, right? It's a kind of code that can resist a lot of changes, and that can allow several parts and several regions and several modules of the system to work together in an easy way, right? Think of a clock which has jewels inside that reduce the friction, and all the moving parts work in a reliable and precise way, right? That would be, these little jewels would be cohesive classes in our code base, or cohesive services, or cohesive functions, right? It's also like a diamond, cohesive code, because most usually the cohesive code of the company, it's the key part in the value chain, right? When we have a record player, a vinyl record player, the most delicate part is the tip, which is the diamond reading the grooves on the disc. And the rest of the machine can be done about metal, can be done with metal, can be done with plastic. It really can be done with any kind of material. But the thing where we rely most on, let's say money, let's say private data, let's say our calculations which are unique in the whole world, like geological calculations on building structure, all these high-end parts of our business deserve to be cohesive code, right? And so most of the times they are. Let's talk about the origin of this cohesive code, right? Like diamonds, again, I'm saying constantly here, cohesive code is like a diamond. I'm saying this also because of the origin, because diamonds grow out of pressure, right? If there's a lot of pressure from the upper floor, upper ground, diamonds get formed down in the bottom. And same happens in code bases. Long-lived code bases, like 20 years old code bases, 40 years old code bases, tend to produce classes, libraries, modules, and patterns that turns to be handy and turns to be useful for the whole company. And they are replicated, and they are they really survived a lot of features and bugs, and they have proven to be cohesive and working, right? So this would be the natural origin of this. I will comment very, very quickly example of natural origin of this. In very old code bases, there used to be a pattern of programming, like a strategy, or let's say a way of working with code, a way of designing. It was a design, the design of the go-to statement, right? This go-to statement, you design the flow of the execution in a specific way, and you told the code to jump from one line to the other, right? With time going on, the go-to turned to be uncohesive. Let's see it. Here there's a go-to statement code, and okay, you can take a look later on. Maybe I can pass you the image, and you can pause the video right now and see the structure. But basically, to actually iterate 5 times through a code base, you need this line to set the counter at 0, this repeat tag here, and a condition that if the counter is still less than 5, go to the repeat, and also a counter incrementing. If we remember our definition of cohesive code, we can see that the module we're building actually have all the changes outside of it, right? We're spreading the changes all around, right? And that makes it difficult to read, to maintain. It makes it more error prone, and it's basically a bad software design, right? What happened there is that someone start using another pattern and start telling other people about it and start implementing in new languages. And that is the for loop, right? Where the increment, the variable, and the exit condition, they are all in a one line module, right? This is a function module, and we have very mixed concerns in it. This is a very a small module with doing one thing well, right? It's a cohesive design, right? I said I would not talk about code, but I couldn't resist to talk about this. So let's talk business again. This kind of cohesive designs that survive, that they that live that has long live inside the code base, and they are so precise, so reliable, and so valuable for the business. They also can be produced in an artificial manner, right? Companies that need diamonds actually discovered that actually realized that the best strategy to get diamonds in a sustained, reliable, predictable, and less costly way was to actually synthesize those diamonds, gather some people together, realize about which are the process that makes generating a diamond cheaper and faster, which is the conditions, which are the like what is required to produce these valuable diamonds, and which in the technology sector, in IT, we would say it's katas, right? We gather with some colleagues and you do a kata to realize how can you create a cohesive piece of code, or even TDD, like it's artificial. It's an artificial practice to process to create cohesive code, reliable code, and so on. And finally, there's this space origin, or diamonds, right? And code, which is that we are in our company, and which is saying like, we're doing our patterns, our way of working, we have our classes, we have our name for specific parts of the code, and suddenly some persons see a video of a guy who is doing something very exotic in San Francisco, and a very breaking and new thing, and shiny and spectacular thing that seems very appealing, and it turns to be very valuable and to contain a lot of cohesiveness in using it. But I would say that these kind of events should be treated like, okay, we have these patterns, we have these cohesive designs, but we are not applying it from day one, right? It's not a way to provide diamonds to our machine, let's say, but it's more a way to receive new information, new knowledge on other ways and other kinds of cohesive code. So it's something to take in a pinch of salt. And at the same time, it can be very engaging, right? So let's study this pattern. Let's study this practice. Let's start using event sourcing. Let's start using any kind of REST design. This thing shall be taken with care and basically learn from it. Learn, like when there's a meteorite, you learn from it. It's not a way to fuel your company write straight away, like the day after, right? Then there's the social aspects of cohesive code, right? We all love to show our belonging to a specific pattern, or language, or practice, like TDD. It's somehow, we create cohesive piece of code, we create these diamonds, but maybe outside of work, maybe in our free time, just to prove we can do that, and we can generate this worthy piece of code by ourselves, and we treasure that. We have our GitHub account, right, where we maybe keep this kind of family jewels, right? This code solution we did with that mentor when we were trying to learn this specific technology, right? And even it can be a way to build engagement in a team, right? So let's all have our ring with diamond, because we're going to build a very nice tool during this hacker week, and we all together are going to be engaged with this piece of code we're going to take care of, and we're going to design it very, very well, right? And also in social events, right, we like to dress well, we like to show tell about ourselves in social events. We choose a specific clock with specific jewels, we choose our specific flair we want to show, and it's very nice to open a conversation out of that, right? And it's really part of our social life as programmers, to use cohesive code, not in a practical way, not in an industrial way, but in a social way, right? And finally, I would like to explore the limits of this diamond, this diamond analogy, and this wheel for diamonds, right? We cannot have huge machines all made of diamonds, right? We have to be pragmatic. We cannot expect every piece of code in our code base to be endurable, to be frictionless, and to be, like so valuable, right? Uh, it's not. I think it's not reasonable for a realistic company, right? And on the other hand, there are other values besides diamonds, right? We may find ourselves, our working space, more like this mine here I pictured, where we basically have to extract materials in a fast way and coordinate along the team and meet that deadline. And there are many, many situations where it's not strictly needed to have to seek for diamonds, right? Uh, but on the other hand, there is, I would be reluctant to say that a company can grow and can be successful avoiding the knowledge of cohesive code, avoiding discussions on code design, avoiding their workers to have a sense, an intuition of what is cohesion, right? And even the most, the most straightforward company that don't want to know anything about uh, uh, facing future changes, that is building a fast prototype, or even the most um, you know uh, is acceptic company with the cohesion and the good design would need at some point diamonds, would need cohesive tools, right? um, we all can appreciate the value of tools such as Git, and Git is a massively cohesive piece of code, right? It helps us a lot. It it keeps uh, it keeps changes isolated, and it doesn't you allow to rewrite on previous modules. And it's really a very interesting piece of code. And same happens with continuous integration and continuous deployment pipelines. In the past, there used to be, let's use this slide here. There used to be the deployment process, which was a module, but someone had some tests in an Excel file. Someone had some private keys that needed to be used at a Google Drive. So all the elements of that intervene in a deployment were spread around, while continuous integration and continuous deployment pipelines are such a handy tool to keep all these changing things in the same module, right? And that's like a very important thing that it's unavoidable, right? Good design is unavoidable, and whenever if you turn to be in a company that is not paying much attention on code design, right, is not valuing good design as a diamond thing, maybe when new tools come, right, that they always tend to come, uh, it's a great idea to have a discussion on why this tool is so handy. What happens with this tool? Why? Uh, so to start reasoning like we did in here with the benefits of the tool. So it's a great way to start discussing about this, start creating a culture that appreciates diamonds, at least as a tool for creating code, for testing code, for managing code, right? So this is everything. Hope you like it. And I would like to end remembering you that uh, there, this is the definition of cohesion, like the module and keeping the changes inside of the module, that it's really worthy, business speaking. And I would like to end up with a comment or line of a writer of Shakespeare that has Hamlet to say, "I could be bound in a nutshell and count myself a king of infinite space, whether it if I didn't had bad dreams, right? I could be very happy with a very static design, closed design, and I could feel like I'm the best programmer in the world, but there will always be change coming, right? So that's pretty much everything. Hope you like it. And now it's your turn. Like, if you have any comment, any thing to add to this, any insight or any opinion would be valuable for me and for the rest of the attendants. So.
Thank you, Lau. Any comment, questions? Don't be shy, just throw it out. I will start actually, I will start myself. Oh, well, Hitesh says, for every change, how can we predict the next change and how it can influence the current refactoring?
Yeah, that is the key behind, yeah, many of the things I said. Predicting the change is the biggest concern you have to have when thinking about design, right? And thing is that most of the times you cannot predict uh, if the company is going to be merged, if there will be a legal audit, if there would be like a very very strange feature coming from 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 a commercial enterprise, from a commercial thing. Uh, my guess here is that you can have two criteria to identify change beforehand. One is the weather of yesterday is similar to the weather of today. That's a thing you can assume many times. And if you had to add a corner case to a class, it's more probable that you have to add a corner case on the following months, right? And the same for if you are doing a thing that is never commented out. It's a part of the code that no one knows. It's a part of the code that people don't know by heart. It's more probable that that part will not require many changes. But again, anything can happen, right? And this,
So in that, would you say in that case that it would be worth it to analyze also the like the commit history of a project in order to determine like past behaviors or past
sure,
changes and
sure.
predict?
Sure. So the best thing I recommend when you come in a project, when you come in a code base, best thing you can do is take a look at the history of that code base, right? How many times there was a bug fix? How many times there was a refactor? Can you understand the names of the commits? Can you tell which part of the service is more important by looking at the commits message, right? So knowing history is a very powerful way to get used to and to predict things in the future. But it's not always happening, right? And um, Hitesh, there's another thing you can do, right? That is actually asking people from business, asking people from product, do you forecast to have, calculation of breaks between meetings? If we follow the example I just said, can you forecast this? Are we having this kind of requirements very often? So you relying on the projects and on the pipeline of commercial of sales and product is a very powerful way to take design decisions actually.
Yeah, thanks, Lau. I think that was really a good explanation, and I really appreciate the commit behavior can be a good criteria in this. One small doubt that I have, like most of the people, they raise this question, like like sometimes what happens is like there is a very thin line between over engineering and a good design. So what people ends up predicting lots of changes in the future, and they eventually turn their design into an over engineering stuff. So what is your say on this?
Yeah, it's not good to do very lots of domain fiction, right? Like getting ready for many changes. Like if you prepare a class for, let's say, 5 or 7 kind of changes in the future, most probably you are being slow and you are not contributing a lot. Uh, what I recommend is like being pragmatic, and I usually, from my daily point of view, my daily work, what I do is I do a git annotate on the class I'm working with, and if I see that there's a rainbow there, like many commits, many different people, many colors, then I say, okay, this class is suffering, this part of the code is under stress. Maybe it's worth to be prepared for the future. If it's a greenfield project, I think there is no much point on anticipating technical changes. And in those cases, I would be constantly asking business and product, right? We're doing something brand new. Are we going to internationalize this? Are we keeping in mind what are the implications for the business of the design you are doing? So hope I answered.
So Lau, is there anything else? Is there anything else you may like to
Yes, I
share?
would like to say that there's a whole things that can be said more about this. One is how cohesive code can be easily sliced, right? That has to do with continuous integration and continuous deployment. When you're doing cohesive code, it's easier to fit features in small pieces instead of doing a release every 1 month or every 2 months with all the changes inside, right? And that thing I would like to talk more about it, but unluckily I didn't have time to prepare for that. And on the other hand, all this Git analysis and all these little tricks that can help to see if the code is being historically uncohesive or historically suffering. I would love to add something in this presentation, but I didn't have time.
But it
So
would be great to have maybe in the future some of those tricks. I've seen you doing that live, and it's amazing. And it would be, I think it would be great to share those tricks with the community.
yes, please let us know with a comment if you want to see this, because it actually takes time. It's uh, it's uh, it's something that it's an effort to put it down. So if you say like you're interested in that, that would be a reason more to to make it real.
Thanks everyone, and thank you, Lau. Amazing talk, and see you next time.
Bye bye. Thank you. Thank you all.